Welcome to another podcast. In this episode, we're going to be taking a look at definite integrals and specifically how to do integration by parts with a definite integral. So the integral that I have in mind to get us started with today is the integral from 2 to 5 of the square root of x times the natural log of x dx. Now this is a prime candidate for integration by parts substitution because we've got a product of two functions and we know that integration by parts is the inverse of the product rule in terms of a application. So we're looking for a function that can be easily differentiated and one that can be easily anti-differentiated. The one that's easily differentiated that makes the problem simpler is picking u to be natural log of x, in which case du is dx over x. If you're unsure of what the integration by parts substitution is supposed to look like, there is a video on that where I derived the integration by parts formula, and so I ask that you watch that. Okay, if I'm going to pick my dv, I want it to be easily anti-differentiated, and the only function left here is the square root of x dx, which, as luck would have it, can be easily anti-differentiated. Remember, the square root of x is x to the 1/2, and so if I take the integral of that, I'm going to add 1 to the power and divide by the new power. So this is going to give me a v of 2/3 x to the 3/2. Okay, if I make my substitution, I do u times v first. And since it is a definite integral, here's how it differs from indefinite. I need to evaluate this first piece. So just like as if it were coming out of an integral, which it kind of is, I evaluate it at the limits 2 and 5. All right? The rest of the formula is now minus the integral of v du. Du in this case is 1 over x, and so I'm going to write that as x to the negative 1. That'll help us do some simplifying in the next step. Okay, let's do the evaluation steps. So I've got 2/3 x at 5 minus the same thing, this time x at 2. All right, then minus, let's take one more crack at simplifying this integral. This is 2/3 x to the 3/2 minus 1 is x to the 1/2. So we are back where we started. So this should be easy to take the integral of. We already have done it. So string everything along. Now here's where you need to be careful. This minus sign can cause students a lot of problems. So here's what I recommend you do. It's minus, and then everything you're going to put from here on out, let's put it inside parentheses. So it's going to be minus the antiderivative of x to the 1/2 is 2/3. We already have a 2/3, and so together that's going to make 4/9. X to the 3/2 evaluated from 2 to 5. Okay, one last line. Okay, we're going to evaluate first at 5. And then normally we would subtract evaluating at 2, but since we already have a negative, it's going to be add this next term at 2. All right, so technically we have an answer. We don't need to put a plus c. This is a definite integral. In Maple, I've already logged this in, and the answer is approximately 6.9970. You can see here in Maple, I went ahead and put in the entire solution. It simplified it wonderfully, so this would be an exact answer. If you could simplify it to this point, that would be great. Maybe try it on your own just to get familiar working with roots. And then this is the approximate value of that to 5 significant digits. Alright, so in general, there is a lot that is the same about doing a definite integral versus an indefinite with integration by parts. There are a couple of main differences here that I just want to highlight for us. Is first, you have to evaluate the piece that you pull out, and second, you've got this minus sign that can cause you problems if you're not careful about it. Those are the two main things that you'll probably need to be aware of. Other than that, though, it's just a straight integration by parts substitution that we started with up front and then carried on through the rest of the problem. All right, thank you for watching.